right, let's give it a start. So, welcome to lecture 2 of software testing. We're going to talk about unit testing and TDD today. So we talked a lot about, last time we talked a lot about different types of, how do you say, testing, ways of testing. We built a vocabulary around certain things. We're going to build up on that today, and we're also going to see some in action, basically. We're going to take a look at a little bit of code as well today. And yeah, we'll see where we go at. So today's lecture, we're going to talk about unit testing, test automation, XUnit, hard to test, and mocking. Cover a little bit about coverage. We're going to also cover that at a later, and a little bit about agile testing and TDD. So that's basically today's lecture. So, all right, unit testing. If you remember from last lecture, we talked about something called system under test, like a unit. What is a unit? A unit can be a function, can be a method. That's the smallest parts of it. Can be a class also. So it kind of depends what the unit is. Can be bigger as well, but usually you sort of, when you talk about unit testing, you usually refer to like testing a class or testing a method, for example. You can use unit testing frameworks to test other aspects as well, but it requires a lot of build-ups, setups and stuff like that in order to work. So we can do this manually. We can do this a bit automatic, or we can use a framework. So, and what do I mean? What do we mean by manual and automated, for example? So let's take a look at some code for that. So manually is basically this. So I will show you. I have my math. I'm not going to show you them because there are bugs in them. So, and they are really stupid bugs. So, but it's more for show and tell, right? So we have a class, my math. Can everyone see it, by the way? Okay, good. And we also have a max function. We come to the max function later, but both are in the same. So if we want to test this manually, we want to construct a program that exercises the function, right? So let's see if we can find the bug in that. I have this static method, scan and run, that takes two numbers and then exercises the add function basically. Let's see. This is going to be a bit tricky, but I think we'll manage. Worked yesterday, so fingers crossed. All right, so what numbers? So also, we don't know the inside of this. We don't know the inside of the add function. So what do we call that? We mentioned it at the end of the lecture last time. There were two concepts. Do you remember? Exactly, black box testing. We don't know how it works. If we had known what was inside the function, it was what in that case?
Glass box?
Glass box. Yeah, glass box or white box testing. So same. Okay, so someone give me two numbers.
7.
7? All right. And another. Sorry? 6. Okay. All right. So that seems to work. So that was not the bug. Okay. Let's try something else. So this is basically manual testing. We enter a lot of numbers. So 12, 11 seems to work. What else? -2. -4. -6 seems to work. Okay. Anything else?
we change one of the number to a 0.
0? Okay. Which one? First or last?
Doesn't matter either.
Okay, let's do 2 and 0. That seems to work. What else?
0.5.
0.5? It has to be or we can try, but I think we require an integer in this one. But we can try. I think it will crash here. So maybe the text should have said integer number in that case. So that could be a bug. It can't add float numbers together, for example. So, but there's another bug in this. So let's see if I can find it. It's really stupid. So, all right. Don't input anything. Yeah, we still will wait for it. So the scan will wait for it. I think. So yeah, it's a kind of stupid program. It waits for you to input something. So all right. Sorry. Yeah, that will crash the program as well, I think. So yeah, it will crash the program. So that's also something that we might have needed to do. There's another bug in. Let's see. Okay. Let's see. So if I do like this, I think that that was really weird. That was really not supposed to be that. Let's see. It feels a bit slow. Java in a nutshell for you. All right, so 10 and 10. That's 21. So stupid bug. So so now we know there's a bug for it. So there's it's on purpose I did this basically. So if it's divisible by 10, we add 1 to the sum. So stupid bug, right? But serves the purpose. So so that was the manual testing part basically. So if we instead look at how we could take it another step forward, basically, we could do this was fairly easy to find, but I think Daniel constructed something like divisible by 35,000 or something like that. So that would be even harder to find that add functions bug, right? So as a developer, we wouldn't create those kind of bugs, right? So, but for the purpose of demonstrating the different parts. So let's see instead if we automate it. So this is one way. So we instead of manually putting the numbers in, we can do like this, right? So we run this, and oh, why didn't that work? Oh, forgot to save the file, of course. All right, so it works. And if we change this to 10, then we expect it to be 21. It still says it works. That's weird. Oh, right. Sorry. I expected it to be buggy. That was my fault. There you go. Doesn't work. Okay, so now we're getting closer to sort of like the unit testing that most developers are used to. This kind of way. We write something simple. We specify what we want or what we expect. We specify the input. So and we check if it works, basically. So that's one way we're doing. That's like a crude up automation of doing testing. right? So this is something that we most likely will use a framework for instead. So, but the principle, we could write like a simple program in order to test it automatically. We could have a bunch of these, for example, and run a test suite around it. So kind of primitive. We talked a bit about random testing last time, if you remember. So here we constructed, so this is the next level. This can actually be very useful if you do a lot of black box testing, for example. You want to exercise a lot of, you have a function that you know nothing about, but you know it's there, like an API call or something like that. You want to bombard it with tens of thousands of random numbers, basically. So I think we're going to lower this a bit to like 1,000. So basically, we want to run 1,000 tests, like bombard it, random numbers, and see what happens, basically. And so we have a little program here. Let's see if we can make this a bit more visible. So bit of printouts and stuff like that. We have a range for -50 to 49. So we don't use the entire range either, because if you remember from last lecture, if we had like a simple add function, all the possible combinations will be a massive amount of combinations, right? So we will never be able to run every number combinations, basically. So that's just, we can't do it, even as a supercomputer. And it would be rather silly to test an add function in that way as well. So, so we want to sort of take a snapshot somewhere and see if we can find the fault here. So let's try and run this. Oh, maybe I should actually do run it as well. That usually helps. All right, let's see what happens. So, and here we can see a lot of failures from 1,000 random tests, basically. And we also see the reliability here. So like the percentage of all these. So we wanted testing to be reliable. We wanted our test to be as reliable as possible, or the code to be as reliable as possible. And we see there are certain cases where this is not very reliable. So we could fix the add function pretty easily, right, to get it 100% reliable in order to for this test at least. So, all right. So, so this is a crude way of doing it. Sometimes you have to do it because you can't do it in another way, for example. So that's that. There are ways we can do this, like using programming languages, code, and stuff like that. So that we can figure out ways to do it outside the framework, for example. And in certain aspects, we have to do it because we can't. Certain codes are exceptionally hard to test through the frameworks, for example. So we might not be able to succeed in doing it. But usually it's more low-level code and stuff like that. So, all right, so that's a bit about that. So we're going to talk a bit more about frameworks a bit later in the lecture. So repetition of the goals of testing. We want to be able to control what we test. So sort of we need to be able to pinpoint where the code that we want to test, basically. So this can be tricky. So, but this is what we want to do. We want to be able to reach the part where the fault is located. We want to be able to produce the error state, and we also need to make the error visible as a failure. So we need observability. So if we have controllability and observability, we have testability. So then we can test it. So if we can reach the code, but there is no way we can actually see the fault, then we're not able to observe the error state, right? So we can't test it. Then we can't test it. So we need to figure out a way to do that. Yeah, and also need to have specification and requirements available to understand what to test and detect failures. So we talked about that last time. The requirements are the ones that steers what we want to test, basically. So we need to figure out the test are supposed to verify that we have done the right thing, right? So, all right. Let's see. Yeah. And our tests, we want them to be as accurate as possible. What that means is that we want to be able to isolate the faulty code, right? So we want to be able to reach it. We also need to isolate it as much as possible. So if you do like manual regression testing, for example, it's not very accurate, I would say. So yeah, and we want to be able to connect them to the code that is under test, basically. So, all right. Let's see. Okay. So yeah, unit testing, like I mentioned in the beginning, a unit can be a lot of things. Can be class, can be a method, can be a component, can be a module, can be, yeah, a lot of things. Also, it depends kind of which language you're using. Unit testing in Java, for example, are usually on the class level, class and method level, but you can also construct unit testing with other stuff like databases and stuff like that. But then we come into the hard part, and we'll reach that a bit later. So it can be done manually. You saw that we did that just recently. We constructed a small program around the add function, for example, and tested it manually. So that's one way of doing it. That's very time consuming because you have to enter all the numbers by hand. So we can automate the input. We can also automate the checking. We can use random testing, and we can use a framework called XUnit. So when we say XUnit, there's usually a framework for different programming languages, for example, that conforms to this kind of testing. So it's usually most of the languages I have encountered has one of these test frameworks, basically. So in Java, it's called JUnit. JavaScript has Jest, for example. I think it's one of those. For Elixir, you have EXUnit, for example. So they're usually a test framework like this that comes with the language or comes as a library to the language, depending on how it's constructed. So most people, when we say unit testing framework, XUnit testing, we mean unit testing framework, basically. So if you hear someone talking about unit testing, usually they refer to this. But like we saw in the beginning, we can do it in slightly different ways, which can be actually good to remember because sometimes you need to do. So, all right. What is gained from a test case? For a specific, so we want, like we said, we want the controllability. So we need to like cherry pick what we send into it. We want to control the data that we send into the test case. So either we get like, okay, yeah, it works, looks good. Or we want to get like a fail from it. So, and this can be different types of failure. It can be code provides unexpected output. So that's usually the case. Like this is what we want. So if we send certain inputs and we get an unexpected output, yeah, we have a bug there, right? So something doesn't really work according to the specifications. So that's usually what we use it for. So other way, well, it could cause a crash, basically crash the program. So then that's something that we need to figure out as well. So if, for example, if we had constructed a unit test with sending a letter to the add function, for example, that would have crashed the function. That would have crashed the program, most likely. So, okay, so we need, that's one way of doing it. We can, okay, we write the test case, and then we write code to protect from that input, basically. So, and sorry about that. It's a bit annoying. So this is something also we want to test and make test around if we need it. And yeah, we can also have exception, for example. That's another way to go. So all the results we get back are valuable feedback. So we want to have these kind of things. So have anyone worked at the company developing software where the code base had been more than 1,000 lines or 10,000 lines of code? Okay, some of you. Okay, so we want to have this because this gives us confidence. So the test cases around this gives us confidence. I worked at a place where I can safely say they used legacy code at that time. Hopefully they've changed it by now. Fingers crossed. And we had classes in Java that were 10,000 rows long. So there was a couple of classes that were about 8,000 to 10,000 rows long. So, and the most horrible thing with that program as well was there were no testing at all in that system. So working with that was like a nightmare. Because and this was quite early in my career as well as a programmer. So it was a kind of horrible experience. At the same time, it's very, very, very valuable experience. But we want to have that. So every time we change something in it, something else could break. So we needed to do manual testing in order to figure out if something broke, basically. So yeah. So we want testing, but test cases can also be wrong. So after all, it becomes another code, a code base, basically, that we need to maintain. So if we change something in the code, we need to also verify that the test keep up with the code, basically. So otherwise, we will have the test frame, the tests and the code basically have diverged from one another, and then we end up in a bad state. Okay, so yeah. So if we have this, for example, this is just like a super simple example. We can basically just add stuff together and we get it wrong. And if we have a function that actually a method that actually passes this test, then we like then we have a bug that we sort of accepts in the code, which is bad. I think you can pretty easily see that it's wrong. I think it should be 65 or something like that, not 56. So we want to write tests that are simple. We want to have enough tests to test the valuable parts of it. And to give us confidence, basically. So this is the tricky part, because we want enough tests to cover everything if we can. But we don't want too much testing as well. So we need to have like enough testing, like lagom testing in Sweden. So Swedish. So you know all know lagom, right? by this. Yeah, okay, cool. Yeah, so lagom is best in this case, because if you have too much testing, some will probably duplicate of the same test case and stuff like that. So we want to avoid that in order to have, because if you have too much test, too much test code to maintain, basically. All right, so input and output. Yeah, yeah, right. So code again. Let's see. I'm gonna take a look at that. Okay, I need to do like this. Okay. So we have another method. We're gonna do a bit of black box testing again. So we have a max function basically here. There's also a small little bug in that. I didn't. It's fun to code bad programs sometimes, but also hard. So I've written a few tests for it here. Basically, we can take a look at it. Some are a bit of a duplicates as well. So in this case, but so as we can see in Java, this is JUnit, for example. So and and this is I call the testing file max test just to separate out all the testing for the max function. Basically, you can do this. You can also name it after the class. I will show you a bit how you can structure it a bit later. So there's a lot of different ways in structuring these kind of things. So we want to have a clear name for the test. For example, test max with positive numbers. So we give max an array of positive integer numbers, for example. So that's one test, pretty good test. So the input is still really simple, right? We don't have like 200 items in the array just because, well, we could have it, but then the test would be, yeah, bloated. So try to keep it as simple as possible. In this case, yeah, a small array of 4 numbers, for example, is pretty good. So we also want to test, and in this we have like a 5, which is the max number. So we expect the 5 as the output. So this is pretty much a simple way of doing it. So then we have like a test with a single element. We have a test where the max number is at the beginning, because we need to figure out the edge cases. First test case we had like in the middle. Okay, so what happens if we put the max number in the beginning? And we also have it at the end. Test max in the middle. Yeah, so another test with, so this one and this one is probably like, these two are pretty duplicates, right? So then one of them could probably go. Test max with duplicates. So here we have equal numbers. So we're trying to sort of figure out, okay, we know there's a bug somewhere, so we need to figure out, okay, what kind of testing because we don't know the interior of the max function. We know there's a bug there, but so we need to surround it with testing that we think that should work, right? So, and test max with 0, test max with large numbers. Okay, so if we run them, let's see. So you can run the test here, for example. That's one way of doing it. You can also run it in the terminal if you want to, but so everyone passes, right? Okay, so what let's see if we can create a test that fails then. Any suggestions? Something comes to mind?
Is this one of those where it becomes a negative number that's this? Like if you put a very big negative number.
Yeah, big negative number, I think. No,
There is a bug.
none of them did negative numbers, right? So all negative numbers, maybe?
I thought a really big negative number. Maybe all. I don't know.
Okay, test max with oh. Let's see. Neg. All right, so I will negative numbers, for example. And see, like that. So we can do -100. Oop, nope. All right, so that should do it. Let's see if we can run this. All right, we got an error. Let's.
I expect it to still be 100.
Right, thanks. Good catch. So what's negative 180, something like that? Why is it? Like this? Right? -100? Right. Thanks. I was still on the add function. I don't know why. All right, let's see if we can. So we wrote a faulty test. Let's see if this is. Why is it failing? So, yep. So you see, here is an error. And this is actually the bug as well. So we got minus, we expected -100, but we got a 0. Anyone know why?
Guessing like it goes through it and it like always checks if the number is bigger, and we start with 0.
Yeah, correct. You're absolutely correct. So once again, stupid bug here. I can show you. So we put max to 0, and if we have all negative numbers, like we still have 0. So this is actually not that uncommon error-wise, basically. So it's if you don't think about it, this is actually something that you could do if you're not careful. All right, so if we basically do any suggestion on how to fix it? Let's see. I think it's something like that, yeah. Min, yeah. Let's see if that works. We can try it. Yep. All right, cool. So we fixed the bug. So having all these kind of tests, for example, in the max test, there's a bunch of them here, right? And so this is what we want you to do in assignment 1, basically. So we want you to write these kind of tests for the code. So it should pass the correct version should pass. And the buggy versions should fail in some aspects. In some tests should fail for them, basically. So this is a pretty good test suite, I would say. And this is like a test suite for the max function. So a test suite can be a different thing, a bunch of things, basically. So this I would call a test suite for the max function or the max method, for example. We also have this is another way of structuring it. I will show you that in a minute, I think. Okay, yeah. So once again, if we have like, we talked about the input domain, do you remember? So that's another word that we used last time, input domain. So we talked about exhaustive testing as well. So if we wanted to exhaustively test this, it would be very, very hard because every part of the array could be a very high number. So it would be exceptionally difficult to test all the combinations. So we can't do exhaustive testing for these kind of things. There is no really good way of doing it because it would take way too long in order to do that. So yeah, so we need to select our testing, and that's what we did. So I had a few tests for the max function, like I selected. You saw the difference between them. There were one duplicate, but otherwise there were like, okay, if the maximum value was at the beginning, if it was at the end, if it was in the middle, if we had negative values and stuff like that. And when we did the negative value test selection, when we all had negative values, then we found the bug. So we selected that kind of input for it. So we need to be, okay, thinking about, okay, what possible combinations do we need to test, sort of like the general case of a method? Because we can't exhaustive test every method because it's an impossibility, basically. Okay, yeah. Let's see now. So when we write test automations, we write code to test software. So we want, and this is a good thing as well, because if you come to like a company that has a well-established test suite for the program, this is actually really good documentation for the software. Because you can basically go in, okay, how is this class supposed to work? And you can go through the testing. Okay, then you know sort of the specification that they expect it to be able to handle. So for us as a developer, as developers, this is good documentation as well, because we can exercise, plus we can run it every time we do a change in the program in order to see if we break it. So, in this case, we also want the test cases to be named in a good way. So we need to figure out a good name for them. If you remember, I had in the max test, for example, it sort of explained what we tested, what was the input that we tested, so I can go through the text line. And also, when we run the tests, let's see if we run the test again. So we also get them here, right? So test max with negative numbers, test and stuff like that. So this is, so we can basically see like a feedback inside the editor as well. What was the testing? Because if that failed, we could, okay, tests with negative numbers failed, for example. Okay, there's something wrong with negative numbers, right? So we want the naming to be as good as possible as well. So let's, I think we need a break. I need a break. I suggest we take like, let's meet back here at 15 over. So it's like 20 minutes. So, okay.
I just like like €5 each.
All right. Let's get started again. I have started the recording again, so let's see if it works. Hopefully. Okay, so let's see. Where were we? Yeah, we were talking about unit testing, right? And we wanted to have like the name for the test should be very descriptive because it helps us in the end. Basically, that's what you want. So a naming strategy is a common naming strategy is to use like system under test, and should, expected, abstract behavior, when for like something like that. So this should, max should work for like negative numbers if we have negative numbers or something like that. So very try to make them as descriptive as possible. Like max should throw a exception for this kind of input or something like that. So also try to keep your test to the point if you can. It's like a specific input and those kind of things. So we want to be able to follow the test in the test code. So like, okay, if we send this in, we get this out. So easy to follow. It's like a story, those kind of things. So quick regression testing. So a lot of unit testing that we do, we automate these kind of things. It's sort of like a regression testing. It's like we want to run all the tests as often as possible, basically, in order to figure out, okay, did I break something? Did something break? So this is where unit testing comes in and is exceptionally good because usually the unit testing are fast to run, but there are cases where it takes a while. So I have worked with a test suite that takes like 5 or 10 minutes to run through, basically. So it's like a coffee break every time you need to run them. But you should aim for them to be as quick as possible because these are the tests that you basically want to run really often when you do development. So basically you do a bit of coding, then you run the test in order to figure out, did I break something, or so sort of. You can, of course, run parts of the tests. For example, most frameworks will allow you to run like a single test file, like a single test even. So you just need to figure out how that works. Apparently there is a error in the documentation that I have. I will see if I can fix that for the Java, because for some reason that didn't work. But most test frameworks have some way of running like a single test if you want to. So if you're working on something specific, you can run that test. Inside the VS Code, for example, you can actually do that as well. Inside the GUI, I can, let's see, I can run this test, for example, by clicking it. So there's usually a graphical interface as well in your editors that allows you to run a single test. Or you can run like the whole test suite here, for example. And this will run all the tests. Right, so let's go back. So we want to strive for as high coverage as we can. So we want most of our code to be testable. This can be exceptionally tricky. So I mentioned during the break here that usually the last 20% are the most tricky parts to actually test. there are certain things that you have to jump through hoops, basically. So in order to reach like 100%, the last percentage of that is usually so hard to test or write test code for that it might even be impossible for it to actually. So if you can find somewhere, if you have like a test coverage of 85, 90%, that's usually really good. So 80% is probably really as good as you can get. But you should strive for as much coverage as you can, basically. So we want to have like a belt and suspenders when we run the test. So we know that most of our code is basically covered by test in some way. That gives us confidence in order to do like refactoring, changing in the code, adding new features and stuff like that. If we can run the test suite and it says like all green, okay, then it should probably work still, right? If we have like, we're 85% sure if we have like a 85 coverage, sort of. So, yeah, also strive for like strong specific test. Don't, in Java, for example, it's not like type of things or something like that. You can do strange things like check if this is the class and stuff like that, but you don't want them as general as that. You want them more specific so you can actually see it, because then it also helps track down the bugs or faults in the system. Because if you can see the specific test that you have right now, and all of a sudden you have a customer comes back and says, oh, this is a bug, for example. If I put this in, it's a bug. Like, so you want to try to recreate that as close as possible to the actual bug in itself. So if you can. So try to do as strong connection as possible, basically, to those. Yeah, so here's a good naming. Should throw exception only on empty array, for example. So that's pretty descriptive. We can see from the test in itself, okay, if we put in an empty array, we should get an exception. So like this is good naming, because then you get really good feedback from the test in itself. All right, so let's see. Yeah, like I mentioned before, these kind of frameworks, they're pretty much for every language there is out there. So I think we can skip that. We mentioned that before. All right, so here it might vary a bit depending on what language you use. So in Java, for example, you have test classes. In other languages, you have like test modules, for example, and stuff like that. So it depends sort of on how the language is formed, but it kind of works in the same way. So you try to figure out what is the unit that you want to test, basically. So a test suite is a collection of test cases, and they usually run together. You can here are different frameworks. You can group them in different ways. I will show you how to be able to do that in JUnit in a little bit. You can run the test. You can get a test report. You can get code coverage, and then we will take a look. Usually they also have some sort of mocking functionality. I will show you how a test report can look like. I think I have it. Let's see if I can do like that. So this is a test report that I generated yesterday. So in this case, we have a package called .com lecture, and we see here the main function has a 0% coverage. The dice function, the dice class has 100% coverage. Hello World class also have 100% coverage. So this is like a report. There are usually plugins for this in the test frameworks. This is a Yakoko or something like that. It's called. I forget Yakoko. up there in the. So, but yeah, so this is a pretty good thing to have every now and again. You usually don't maybe do it every time you run it, but sometimes you want to make sure that, okay, do we still have a decent test coverage? Because if you start adding features, for example, and you forget to do the testing, then the code coverage goes down, right? Because yeah, so that's how it looks, and it's pretty simple to. Let's see. What is it? Okay, let's do it like this. Ingenting. It's a bit tricky. Nope. Let's see. There's usually a icon there. No, it appears. Okay. Let's see if I can. I don't really. There's a command for running it in Grada I forgot about. Exactly. I can see if I can find it later, but it's not important. There's a command basically to run to get the test report, and then it ends up in the build folder. So yeah, let's see. Maximize it again. Let's go back to this. All right. What was I? Yeah, so code coverage, mocking. Okay, yeah. So now we come to the hard parts, basically. So certain things are difficult to test, like side effects, for example, exceptionally. So if you have like a method that writes to a database, for example, hard to test. Because then in order to figure out if you actually stored something in the database, you have to store it in the database and somehow get it out of the database, right? So, and those tests, a test like that will be exceptionally slow. It will be as slow as possible. And also you also end up in tricky situations, but because sometimes you need to have like already data in the database in order to actually do something that causes a side effect. So it's tricky. So what we can do then is like we can use mocking frameworks in order to make sure that, okay, we call this method basically with this type of values. That's one way of doing it, for example. So that's one way. So it's yeah, complex code. This is complex code. If you, like you said, if we do glass box testing, for example, and someone else wrote the code, and we don't really understand the code, that can be tricky as well. So that's why we very much would like to write clean code as much as possible, basically. So the easier the code is to understand, it's easier to write tests for it. So once again, it's like avoid smart coding, like smart coding in quotation marks, because that usually ends up being quite complex. So even if you yourself go back 6 months later and look at the code and say, who wrote this code? Oh shit, I did. So it happens. So try to keep your code as simple as possible. That's my best advice for you. because it's easier to test, it's easier to understand. So write it as simple as possible. Static code is also tricky to test. Error handling can be tricky as well. Usually it's like throwing if it's an exception, for example, that is usually included in like test frameworks, a way to test that. But it can be tricky to reach that part somehow. So that can be object creations, like having object creations in Java, for example. So like, how do you test like calling the constructor, for example? There's no easy way of doing that. So, but you could do like a use factory pattern, for example, because the returns like an object of that class in that case. Because that's easier because then you can basically you can use mocking and stuff like that. Yeah, dependency, database files. You will end up in places where it's hard to test, basically. And usually you run into that fairly quickly as well. So some frameworks do have some support in order to do certain things, but you need to figure out how to do testing around certain dependencies like database and files and stuff like that can be exception tricky as well. You can probably do mocking as well in this case. So mock is a very versatile tool, but it's also quite tricky to actually do it. We will see about how to use it a little bit. So yeah, so no return value. This is what I mentioned first. Basically, if we write to a database, you write to a file. Okay, so if you write to a file, that's a side effect. Doesn't necessarily return a value. So we need to, write to a file, and then we need to open a file and try to read the file inside it. So once again, it becomes like a lot of things you need to do in order to verify that I actually did something. So can also be solved by mocking basically in certain aspects. So I think we mentioned this in the first lecture, indeterministic code that basically flaky test, right? We talked about dates, I think. So if you get today's date and then you run the same test tomorrow, you get a different date, right? So, or if you have a time aspects in that, you even get that pretty early on. So tricky. So yeah, so that's so that is random values, time, for example. Those are tricky stuff to test. So you will run into some problems. Certain things you might be able to solve by mocking it. Random and date and stuff like that you can do, because then you can basically say, okay, if you call this random function or method, you will get this value in return, basically. So we say that if you like today's date or something like that, we can actually specify what today's date should be like, for example. So, but if you do that, it's important that all your tests in that case, or the code in itself, actually supports being able to mock those kind of things. Because if you have like method inside that in itself then calls another date function, for example, that might be cause very strange conflicts, basically. So if that is once again based on what the system's date is, for example, so tricky. Yeah. Yeah. So tricky. This is well. we as oracles, as if we run like the program and we want to check the console outlog, we could be the oracle to determine if the output is correct, right? But to automate this is tricky. But yeah, there is something called dependency injection. So if we have this, if we have dependencies in a system, for example, it becomes tricky. So we could use something called dependency injection. Is that when we pass when we create like a database, for example, let's say we have a database class, for example, we could pass the database connector into a class that deals with it, because then we can basically mock the database adapter or connector, basically, in order to do the testing slightly easier. So yeah, there's a link to an article that is pretty good about this. All right. So mocking. So we're going to take a look at how to solve this by mocking. I have like the hello world example is my mocking example. So basically, you can do a couple of things with mocking. You could replace like a difficult dependency by saying, okay, I want to sort of mock this class that I send in like a dependency injection, for example. And because I want to specify what values you get out when you call certain methods, for example. So we're going to take a look at how that. So that's one way. So we fake the output, basically. That's one way of doing it. Another one another thing we can do with mocking is that we actually can measure, okay, was this method actually called? And how was it called, for example? We expect it to be called with this value, for example. So yeah, so it could look like this. We're going to take a look at another example later on in just a minute. So there's in Java there's a library called Mockito, basically. So this looks kind of cryptic, right? Or it's not the easiest to read. But we will take a look at it. So basically, oh no, you can't do that. Okay, so basically we wrap a class in like a mock call. So the mock framework then creates like a wrapper around the class, basically. So you can actually say that, okay, when this method is called, for example, you should return yada yada, or was this method called? So basically we can do this kind of things. I think we're going to take a look at the hello world example. Let's see. So kind of stupid. So basically, the first one is we just print something in the console. This is something that we've seen before, guaranteed. So this can be kind of hard to test, right? Or how would you do it? So we could mock the system class, basically, in this case, because system is in itself a class, for example. So we're going to take a look at how that is done. The one that says hello with DI is dependency injection. What we do there is we send in the print stream instead, basically. So that's what we do. There's a couple of things. So So here we send in the class that actually does the printing. So we will see why this is better than this in just a minute, basically, when we take a look at the testing. So let's see, we can make this a little bit bigger. All right, so we do a bit of setup. We have for both, so we haven't seen this. Setup is basically something that is run before each test run. So before the test is run, we do something. So in this case, we create like an instance of the class of Hello World. So if you have a lot of things that if you do this for every test, for example, it might be nice to put it in a setup function or a setup method. So before each, so let's see. Okay, so test Hello World directly. So we need to do a lot of hoops here, right? We need to set the output streams in order to test it. We need to sort of do a lot of things. And we also need to restore at the end of the test, because if we don't, we might create a lot of strange errors, basically. So we want to say that, okay, system, this is the output stream. This is the new print stream that we want, basically, that you're going to use. And then we want to basically have a look at that. So like inside. So we need to sort of, in this case, make a lot of hoops. So that's one way of doing it. It's tricky. So in this case, we don't use a mock. We use a redirect, basically. So if we have like the dependency injection instead, we can mock that. So what we do is we wrap the print stream class in this case, and we can verify that the print line function was called with that value, basically. So that's how we verify in this case, is that, okay, this object, which is now the print stream that we're using, is that we verified that that method was called on that wrapper, basically. So it's difficult to explain. Apparently. So that's how you can use it, basically. So it's slightly, you have to get used to doing it, wrapping the classes in this way when you want to write the testing for it. So it's not the easiest to get started with, but it's good to know how to do it, basically. All right. So we talked about coverage. We wanted to reach, like, I'm not sure about the code coverage we've spoken about. So this is like a inside of Eclipse, I think, the Eclipse editor for Java. Like, this is like the output for that. So most editors have some way of displaying these kind of things. All right. So test-driven development. So basically what you can take about mocking is that it's a powerful tool. It's a bit tricky to get used to. That's pretty much it. I think I will show you the other example, by the way. Sorry. One more example of, I had a dice. So we have a simple, this might be easy to understand, actually. So simple dice program. It's like roll a six-sided die, for example. So but we use a random there's a random to it. So if we wanted to write test for this, all right, yeah, this is, was it? Okay, let's take a look at this first. So if you see, there are the setup here is slightly different than before. It's a lot of more like tag stuff here. So this is a different way of organizing the tests, basically. So we can take a look at that, because this is like a so if we wanted to write this without mocking, it's like very unpredictable. So we can assert that we get a value between 1 and 6, or something like that. That's pretty much what we could do. But if we wanted to control it a bit more, like more predictable, we could wrap the random class in a mock. So when random next int with this, then we return this. So basically we are forcing, so when we call the random function with the next integer, giving the next random number, we say that, oh, you should always return 4. So in this case, because it's a random number between 0 and the top bound, we need to make sure that we add like 1. So in this case, the 4 is actually a 5. I know it's weird. So in this case, we send the mocked random class like a dependency injection, and use that function basically. And then when we roll inside of this roll function, there's a call to the random. Let's see if I can. Open this again. So here, basically, we call random with a +1. So we wrap this, and when the next int function, we return a 4. So we send that, because when we create a dice object, we send in the random class like a dependency injection with a dependency injection. So for this test, we wrap a mock around it, basically, so we can control the output values from the function or from the methods of that class. So then we can write something like that. We expect it to get a 5 when we roll, because we force it. We say that it should always return a 5 in the end. So, and we can also verify that did it call random correctly, for example. So yeah, it did. So we can construct a few around this. So what I wanted to show as well is here that display name is the name that is outputted in the test in this case. So without mocking is the one that I think if I run hopefully it should somewhere, let's see, dice. So you see here the output. Dice with mocking, predictable roll returns value of 1. So basically we can nest how we display it. So it can be a good way of doing it. You don't have to do it. I would say start with naming your functions, test functions in a good way. So this is the other way of doing it, right? So the display name is something that you can basically use. So you see here dice without mocking here is unpredictable. Returns a value between 1 and 6. So frameworks have different ways of displaying it. I think Jest has something called describe, for example. I know that EX units have something like that as well. So there are ways to like organize your tests. And that's also one. So keep your test well organized as well, because it helps. It's like documentation. You want it in some orderly fashions in order to be able to see all the things that are easily displayed, basically. So this is a way you can nest it. You can make a nested class. So you have a public class, and then you have a nested class within that, and you have a display name, which basically, so when we run a test inside of this nested class, we display this first, and then we display the next part as well. So it's a lot of things you can do with these frameworks. You can just read upon it yourself, basically. But there are really nice way of doing it. And you can also skip testing. I think I have this in. Let's see, where did I put that? Yeah, right here. So here I have disabled it, basically, because this would otherwise fail. So I've disabled the test for now. And when we run it here, we have a notion of some of the test was actually skipped because I've disabled them. So they will print out just that we skipped them, basically. Another way you can do it is like tag certain test cases, certain tests, for example. You can give them a tag, and then you can, then the JUnit framework will allow you to run only those that with that tag, basically. So there are a lot of things that you can do with these kind of frameworks as well. So it's a lot of nice things. All right, let's see. Okay, so we can start by talk about TDD, for example. Okay, so now we know how to write basic tests, so to say. So TDD, kind of a controversial topic. Some hate it, some love it, some finds it okay, I think. So there's a whole spectrum of people liking it, disliking it. And it usually goes in waves as well, if it's popular and if it's not popular and stuff like that. So yeah. So before we had sort of agile testing, have you heard about the waterfall method, for example? I guess you have. Okay, yeah. So at that time, you wrote the requirements, and then you sort of throw them out over the fence and said, go implement this, basically. So, and then you implemented it, and then you had like, you had to test it. A lot of those times it was manual testing, so it was kind of hard. If you remember when I talked about my time at SPCS, for example, back in the days, like 25, 27 years ago, we sort of helped out doing this. But the test department at that place also did this every day, more or less. They also wrote some installation scripts, stuff like that, but a lot of testing was done manually. So this is the good old days. We don't want it back. But it also caused like a competition between. It could cause a competition between the testers and the programmers. The testers, they had like an incentive of finding the bugs. The programmers sort of tried to avoid getting a lot of bugs back in order to fix them, for example. So, because if you don't have the automated test frameworks, we haven't always had it. Sort of, they are kind of new. I would say they are probably 15, 20 years old, most of them, but we haven't always had them. So that's important to to remember. It's like we didn't always have them. And nowadays we do have them. So, but at some places, I think Daniel mentioned that he interviewed like a tester at a company at one time, and they had like a incentive. They actually got paid more if they found more bugs. So, and the programmers got paid to not write bugs. So if the testers come back and they found, oh, we found these bugs. So nope, it's supposed to be that like that. So it's a feature. So maybe that's where that sort of comes from. But yeah, so it's not a good way. Industry still struggles with finding good ways in motivating the entire development and testing department. But yeah, so and also we got a super long turnaround. Like you coded, it has to do a lot of testing, and you found a lot of bugs, and you have to go back and so and regression testing for these kind of things are a pain. It's like, I know I was one of them doing actually the regression testing, because that's usually what you get when you get these manual gate documents basically and go through. So yeah, a lot of manual testing, maybe not a lot of automated testing basically. So let's see. Okay, yeah. So slow tests, you can read for yourself. I take a sip of water. So yeah, if you had an automated test suite, for example, it could take a long time. So 2 weeks, that's quite a long time. I don't want to be the person that actually made a mistake in that somewhere in like, okay, yeah, it ran for a week and then it broke. Then that would be kind of annoying because you had to start over again, right? So, and also each test needed a database setup. So this can be a problem for, this is even a modern problem, I would say. Because if you want to run certain tests, for example, you might need a database setup for it. So it might be tricky in order to actually figure out how to do that. And so in certain cases, you can actually like write database script in order to set up some basic functionality. So you set the database in a certain state, for example, and then you can run certain tests. But then you know the state of the database, for example. So that's one way of doing it. It's kind of okay to do it sometimes, but I would say try to avoid it if you can. All right. I think we're going to take a break there. I feel my throat needs a break at least. So we're going to go back. Let's. All right. So before the break, we're talking about TDD, or at least previous, what was previous before agile testing. Programmers back in the days, one of them was Kent Beck, basically. They tried to figure out other ways to do better, solve this better, basically, instead of having like a ton of requirements and basically doing, yeah, this tedious long loop, sort of. So agile testing sort of comes from an agile methodology called extreme programming, basically. So what you wanted to do was sit in pairs and do like testing and coding at the same time, basically. So TDD is born at this time as well. So you wrote the test and then you wrote code for it. So that's pretty much it. But agile testing, we still have requirements that leads to tests. So we'll still have the requirements. We don't just figure out willy-nilly what to do, basically, but we still have some requirements for the system that we want to build, and those still guides what we are going to test. But we sort of test it closer to the implementation. So And usually inside of an agile team, you have both programmers and testers, and sometimes those roles are not very clear defined. So most of the times developers do the testing as well. It depends on the size of the teams, I would say. So yeah, so we have shorter turnaround because we try to automate as much as we can. So the turnaround for like the regression testing and stuff like that are shorter. And that's what we want to do. We want to have a quicker regression testing, basically. So basically, doing the manual testing is more like sort of ocular verification that everything is okay in the system. Usually, the unit tests and the test suites that we have give us as much confidence that we can actually release on a regular basis. So, and then we will come to like certain aspects like continuous integration, continuous delivery, for example. If you do continuous integration and delivery, for example, you definitely want like a strong test base in order to do that, because you don't want to continuously just push out code that you don't know if it works, basically. So when we so we want a lot of automated testing as much as we can, basically, in order to facilitate this aspect. So CI/CD is something that has come at later years, basically. In the beginning of Agile, it was more like trying to shorten the development cycles and also trying to gain as much confidence as possible in your code. So you wanted to do testing. So and like I mentioned before, for the break, TDD, for example, as like a, let's see if I can, that usually happens. All right, yeah. So TDD is something that, like I said, came from extreme programming at the time. I don't know if it was Kent Beck in itself that actually sort of minted the thing. I'm not sure, but he has written a book about it at least. So, which is one of the books for the course. So test development, test first compared to test last. So usually, a lot of times we write code first and then we write test suites for it. So in TDD we flip this basically, and the reason why we want to do this is that basically we want to sort of try to create like a test suite of tests and code that just solves those tests, basically. So we get a pretty optimized code when we do this. So that's a really good thing. Otherwise, you usually write the code and then we write the test suite around it. So it's not necessarily the code is that optimized in order for the test suite to fit together. So, but it's kind of slow. Yeah, so it is a bit slower. I think that yeah, so it usually takes a bit longer. So IBM, for example, they did, was it, yeah, IBM and Microsoft, they tried this, and so it took 15 to 35% longer, but your code got 40 to 90% better. So the quality of the code increased, but you also slowed it down development a bit wise. So, so one of the things that I think that the previous slide. So it is kind of a bit of like designing as well, because if we write tests, we'll figure out we start somewhere and try to figure out, okay, what should this class method do? Okay, and take the first small step basically in order to that, and then we increase that and increase that, and we do refactoring and stuff like that. We'll come to that. So, so the basic of TDD is red-green refactor is something that you probably heard. If you take a look at part 2 of the first assignment, you've heard these kind of things. All right, so step one. Oh, sorry. Step one is basically you write a simple test. So once again, the test should be really simple. And this is very specific to TDD, for example. It should be really simple. It's like this should throw an exception or something like that. Or the add method should add these two numbers together or something like that. So, and then we test the test. We run the test in order to see it fail. So that's the red part. So we run the test, make sure that it actually fails. Because if we sort of have written already a few tests for a method, for example, and you write a new test and it doesn't fail, then it's an unnecessary test because that test coverage, we already have that in that case. So that test can be removed, so it doesn't change anything, right? Because it goes through. So that test coverage is already there. So we want to see it fail, and then we want to make the little change that actually flips it so it becomes green. So this is how you grow your function. So basically you write the test first and you don't even have a class, so it should fail. It should really fail. And then you sort of build the method part by part. So it's small increments, basically. And then you run them again, make sure that, okay, everything is green. And then if we want to do something, if like we have injected like a duplication in the code or something like that, we can refactor. We run the test again in order to make sure that everything is hunky-dory. And then we basically do like a commit or something like that. So basically you could do like in your commit history, you could basically do like a test, and then you can commit that test, and then you can sort of continue doing that, solve the test, and then commit that. That's one way of going, for example. Yeah, so if we have like an example here, for example, should throw an exception. So this is the test that we write. We want to create like a Sudoku board, should throw an exception on a null board, for example. That's a simple test. Okay, so if the board in itself is null, we should throw an exception. So in order for this to even start working or for even to fail, we need to sort of create like a skeleton class. Otherwise we get like the compiler would complain a lot that this class doesn't exist. So we need to create the class, but this should still fail. So here we expect an exception, but it wasn't thrown, so nothing, so it fails. So what we do is that we do a really stupid thing. So the Sudoku board in itself, no matter the state, will throw an illegal argument exception. So, but that solves the test, right? Because now all of a sudden this is green. So it's a stupid method, but it's the smallest increment we can make in order for it to succeed. So that's how we sort of build upon it, one piece by piece. So, and so, yeah. Next step is if we need to change it, refactoring, sort of, then we do that. If we added like duplications and stuff like that, we might want to combine them in some way and stuff like that. So that's the basic of TDD. So the same principle goes, so try not to repeat yourself, the basic design features and stuff like that when you develop. But the base principle is that add something small in order to make the test pass. If you have the test that pass, you can then, with confidence, refactor the function and rerun the test in order to make sure that everything is okay again, basically. So we get confident that the method actually does all the things that we want it to do. Yeah. So in the refactoring, we can do a lot of things. We can extract private methods, improve understandability. We might want to reshape the code in different ways. So basically, yeah. So, and after we've done some refactoring, we run the tests again. So then we get back to the principle again. We write a new test and then keep on going, basically. So I think that's the last slide. So I thought we will try and do some simple TDD. And it's a silly example, but it will work for this case. Let's see. Let's. Dun, dun, dun. All right. Have you heard about FizzBuzz? How many of us heard about FizzBuzz? Okay. Yeah, so cool. A couple of. So it's kind of a classic example. Basically, what you want to do is if it's divisible by 3, it prints. So the input is an integer. So in certain cases, either it prints like the string of the integer. If it's divisible by 3, it prints fizz. If it's divisible by 5, it prints buzz. And if it's both divisible by 3 and 5, it prints fizzbuzz. So silly example, but we will get the principle basically on what we do. Yeah. So this will be our first example, our first test, I guess, if you all agree. So test returns number as string. So in this case, yeah, I need to remove this. So if we now run this, it should fail, right? Yeah, so, and it fails because we don't have the FizzBuzz class, right? So we need to create that. So let's do that. Yeah. Usually don't code in public. Let's see. Let's go back and rerun the tests. So, still, now it doesn't complain here at least. Now it complains here that the method convert doesn't exist. Wait. So we need to add that in that case. Public. It should return a string, right? And convert. Takes an integer n, for example. And what's the simplest way of solving the test? If we take a look. What's the absolute simplest way to solve the test? It's to return the string, right? Yeah. No, that was wrong. So return like this. So if we try that and we try to rerun the tests, did it? It looks like it passed. Why didn't it update there? We don't need that anymore, at least. Please post. Yep, so it's green there. For some reason, it's not green here. I don't know why. Continue. Bottom right. Ah, there. Okay. Thanks. Didn't see that. All right. So, what would be the next step? Any suggestions? So we did a test. We fixed the broken test. So now we need to add another test, right? Okay, so
But it can work instead of restarting the strip.
yeah. So so in this case, the next thing to do would be to add a test to make sure that. So what happens if we return? If we expect it to return a 2, for example. Test returns number as string. Returns 2 as a string. Something like that. Does it fail or pass? Can I run it there? So this fails, right? Because we return a hard-coded string, right? So, okay, so now we need to figure out how do we fix that. So this is the next step. You see how we evolved our thinking here? First, we just wanted to return a 1, and then we
Pass up to
sure, yes. Thank you. You're absolutely correct. And this should still fail, hopefully. Yeah. Okay, so it's still we get a 1 back. We should be 2, right? So we need to figure out how to fix this. So any suggestions on how to do that? So this needs to be fixed, right? What we return here. What if we do, stop that. If we do string value of n, for example, would that fix the problem? You think? Should, va? Okay. Yeah, looks like it fixed the problem. Okay. So do you sort of get the feel on how to do this? Like this, so far it's pretty easy, right? It's not too difficult. Yeah, okay. So what would be the next test? So now it's passing, so we need another test, right? If we're going to keep up with the TDD part. So test returns, if we do like 3, should return fizz, right? So if we pass, I have a different keyboard setup at home, so this becomes a bit tricky. So this should, so this is the next part. And yeah, so free is not, the string free is not equal to fis, right? So how do we fix this? Any suggestions?
Then sort of,
If n equals 3, you return this.
Uh-huh. Yeah. Let's try and see what happens. If n equals 3, something like that, return fis. Let's try that. Hey, works. Cool. That's a good fix of that. All right, so what would be the next test? Sorry?
Like 5.
Yeah, so I think we can do one more test for divisible by 3, because now we're hard-coded the 3, right? So if we do 6, for example, it should also return fis, right? So, oops. Let's see. So if we do, so we need to change this. 6 should return this. All right, cool. And so if we run this, we get a failing test. And we see here, it's VS Code is very nice to give us, okay, this is not, they are not equal. So how do we solve this?
If n modulo 3 equals 0.
It's like this, right? If I remember correctly. Does it look correct? All right, let's give it a go. Wait, okay, cool. So now we have this. So now we feel like fis is okay, right? Yeah, so now we can go to bussy thing. So let's try this. It's probably itching to do like a double copy here, because we probably know that we need to test 5 and 10, for example, but try not to do that. I wanted to do it, so I know the temptation. So 5 should return bus, right? Okay. So we change this bus. And if we set this like this, and then we will run there, expected was 5. Okay, so how do we fix this? Okay. So you want to copy this, or the F? I'm not sure I follow.
F and n equals 5.
And F. Okay, yeah, got it. Before or after? Let's put it here. If n equals 5. Return. All right, cool. All right, yeah, that works. So then we need like another test for. So 10 is a good kind of good number, I think. And that was wrong. Let's see. What? Okay, that's why. Now I get it. So 10 like that, and we run that, and we get an error. And I think we can probably figure out how to fix this. Pretty easy. Like the same. And we run it again. All right, cool. So it's kind of nice. We have a bunch of tests so far. Okay, why is that there? So by doing this, you get tests as you go along, basically. So you have tests that actually make sure that you cover most of it. So if we run a coverage for this, it's most likely 100%, right? Almost, at least. So, okay. So what would be in the next step?
Test for 0. Test for 0.
0 or 15. Okay. A 0 should return a straight. So we send in 0. And it should be fizz bus. Okay. So it returns fizz. Okay. And if here. All right. If it's 0, return fizz. All right. Cool. Yeah. That solved it. All right. So what would we do next? Test for 15. Okay. Let's do that. So 15. It's probably misspelled that, but doesn't matter. All right, so that doesn't work. All right, return fizz. So how do we solve that?
Refactoring more, probably. First grade and MP string.
And or 3 and in both side is both 0.
Okay, you agree?
Yeah,
Okay,
that works.
that's right. So this we want to change to be like percentage 3 equals 0 and n percentage 5, something like that. Was that what you had in mind? Okay, that's right. All right, cool. Seems to have solved it. All right. So we can probably do, there's a lot of if statement here. So we could probably clean that up if we wanted to, for example. That's one way of going. We could make a nice private function is divisible by something like that. That's one way of going, I guess. So we can do something like that. So I will copy paste just to speed things up. I will do like this. Something like this, for example. Private Boolean function, and this will not work for this, right? For this case, it would work for this singular case, for example. So, but we could do so we can change this to this, for example. Let's see. I'm cheating a bit here because I see time is running out. So this should basically, right, yeah. So we name that N. Change that here. Shouldn't matter that much. And once again, got that. All right, so this will probably fail. And okay, no. Yeah, so this actually works because 15 is still like if we try to divide 0 by 15, we still get like okay. So this is one way of refactoring. This sort of cleans it up a bit. So like a refactoring step. And when we ran it, it still worked, right? So that's kind of nice. So basically, this is how you do sort of a simplified TDD session. And usually usually when you do TDD, as one thing you can do is actually do like in pairs. So it's kind of sort of like we did now. We came up with an idea on a test, and then so it's kind of you can do something called TDD ping pong, for example, where one comes up with a test and the other writes code that actually sort of solves the test in that case. So there are a lot of fun things you can do around these kind of things. Just Google it and you'll probably figure out how to do a lot of things. Right. So I just wanted to quickly finish because I see time is almost over. There are a couple of good books. If you haven't read this one, I recommend reading it because sure, it's a bit old, but the ideas inside of the book is really good and sort of timeless, actually. So it's a pretty good book. The one in the middle is the test-driven development book by Kent Beck, which is part of the course. So also recommend reading that because it's a pretty easy read, I would say. I think the last chapters are probably, if I remember, were a bit more advanced, but the start of the book is where he talks about TDD and how to do it is really good. And yeah, it's a fairly complicated example, I think. It was something about currency conversion, I think. Something like that. So kind of tricky. And yeah, the one is XUnit patterns. It's like if you use one of the uni frameworks, this kind of good inspirations, basically. So yeah, I think we will finish that for today. I hope that this was okay with you guys. And I will see you on Friday, I think.